Hi there, I'm Clément. So, my development environment used to look like this, and now, thanks to what we are building today, it's gonna be looking like this. Of course, I'm lazy, so we're gonna have to reuse some stuff, and for example, we're gonna start with a Gridfinity base on which we are gonna build some tiny bases for our PCBs. So come, and with magnets, everything gets attached. I entertained a few solutions that would be universal and where you would print something and reuse it for all of your project. That includes some type of a sliding mechanism that would catch the PCBs on the side, and another one that was an XY plate that you could move, translate it in one direction or another, like an optical plate kind of things. Those are great, but they are very complicated and they end up not really matching my application. They take a lot of space, they can sometimes cost a bit of money, not the best. In the end, those universal solutions were not really what I wanted, and so we're gonna have to do something that is custom specific for each PCB that you get. So let's build something that is custom for our PCBs. We're still gonna have to use some type of a plate in which we can glue different PCBs together, and of course currently the standard to use is going to be Gridfinity. Now we just have to build those custom plates to attach a PCB onto Gridfinity. Let's see what internet can offer. And of course, as often, internet does deliver. I found this project that seems almost perfect. That is called turbocase, where you input your PCB files from KiCad and it spits out a 3D box for you. Isn't it wonderful? We just have to remove the walls around it, just keep the base, add some Gridfinity-ness to it, and we're good to go. So if we look at the README, we can see that we can actually already configure the thickness of the bottom of the box, the thickness of the walls. Gonna have to test if 0 does not make everything explode, but that'd be convenient to remove them. And we can also control the standoff, how high the PCB is compared to the bottom of the box. So it's all looking good on that. All we got to do is to add the Gridfinity part of it, and we should be good to go. Let's just have a look into the code. How does it work? Oh, that's how it works. They seem to be using some template that is directly in the Python script, and so that's going to make it a lot harder to modify. So now we are at a stage that I'm okay with, where now I'm using Jinja 2 as a template engine, in which you give it from the template folder a bunch of templates. Those are OpenSCAD templates where it just includes all the one. This one is a better one. At least that way it's a bit more readable, but most importantly, now I added that in the README, we can select with a new option the template that we want to use. Do we want to use the base template, the one that was already there in turbocase that is doing a proper box for you? Or do you want to use the Gridfinity one where the bottom of the box is actually Gridfinity compatible, like that. The Gridfinity part of this project comes from the MonoSCAD repository here, that got a bunch of stuff designed with OpenSCAD and includes a Gridfinity folder with a bunch of stuff that include some automated box, which are great, like that. Put your label, and in it you can keep all your regular Gridfinity stuff. There, in that precise project, we are just taking the bottom of it, the bottom squares from the OpenSCAD, and applying it to the PCB being generated, the PCB box that we are generating in Python. And now we print. Well, first we'll design the board. So this system uses KiCad as a source. I tend to do my stuff in Altium Designer, so if your PCB is already in KiCad, fantastic. If it's not, well, it's going to be very easy, because all you got to do is to draw a rectangle from the edge cuts on the edge cuts layer. So click on the rectangle, click on the edge cuts, draw your PCB however you want. If you double click on it, you're gonna get a window that tells you the size of it. For example, mine is going to be 100 by 100 millimeters. And now all we got to do is to add the footprints of the holes that we got on our PCB. So we can place footprints. In my case, we're going to imagine that I got some M3 holes. If we take, for example, that one, sounds good enough. M3 here, click again, enter M3, M3. And the key feature that works really nicely is that if you zoom in, you select your hole, you can do right click, we can do position relative to, and if we select the item to get relative to the edge, we can position the hole relative to the edge. So for example, we got 2 millimeters and 2 millimeters. If we let the turbocase script run with the walls at a size of 0, we can actually get something like that with the Gridfinity template below that matches the 4 holes that we need, and 3 holes in that case, but it can be whatever you need. And now all we got to do is to actually render and then export as an STL, and let's print that.
Wait, what? What are you waiting for? It's clearly broken. Come on, come back down. The parts are already printed in the office.
We got it printed here. You just add some M3 inserts where they need to be, add magnets when they need to go. In the KiCad you can make them as small as you need or as big as you need. That's okay. The system will automatically scale the Gridfinity based on how big your PCB is, and then you can simply plonk them onto your Gridfinity grid. I hope this helps you clean up your lab and have something properly organized and spend less time rebuilding your setups when you have to rebuild them. Because now they are still always built, so that's convenient. That's it. All the links needed to actually build it yourself are in the description. See you!